In this class, we are going to discuss about the single phase fully controlled rectifier with a RL load, continuous load current. The last class we have discussed about the single phase fully controlled rectifier with RL load, discontinuous load current. Now, what is the difference between the discontinuous load current and continuous load current means? In case of discontinuous load current, this magnitude of this load current is coming to the 0. For continuous load current, the magnitude of this load current does not come to the 0. Nothing but the load is consisting a high amount of the inductance. Moreover, the load always find a closed path to the supply. Explain the circuit operation. We have taken the input voltage VAB voltage and VBA voltage. The VBA voltage we represented with a dotted line. Again, we are applying the triggering voltage to the T1, T2 whenever the VAB voltage is positive. Nothing but alpha at 5 plus alpha. T3, T4, we are applying the triggering voltage at a VBA voltage is positive, that is at a 5 plus alpha and 3 pi plus alpha, that we have shown here. Now we are going to develop the output voltage waveform from alpha. At alpha T1, T2 is on. Once the T1, T2 is on, the load is connected to the VAB through the source. So the current is passing from source T1, load T2, again return to the source. So the load voltage is equal to VAB voltage up to pi. Because of the inductance, this inductor is not allowing sudden increasing and sudden decreasing of the current. So the T1, T2 will be forced to conduct up to pi plus alpha, up to this point. At a pi plus alpha and T3, T4 is on, the current is transferred from T1, T2 to T3, T4. So the current through the T1, T2 is coming to 0. It will be turns off and T3, T4 will be on at a pi plus alpha. Nothing but at this point. T3, T4 is on. So the output voltage is equal to VBA voltage. Let's see how the VBA voltage. It will be conducting up to 2 pi plus alpha. Up to here. Again at this point, T1, T2 is on. T3, T4 will be off. The output voltage becomes a VAB voltage. The same circuit operation is repeated. If you draw the current waveform at alpha, the minimum value of load current is maintained. The load is subject to positive voltage, so this current is increases to the maximum value. From pi to pi plus alpha, the load is subject to negative voltage, so this current will be decreases to the minimum value. It is not coming to the 0 because it is a continuous load current. Again at pi plus alpha, again load is subject to positive voltage, increases and decreases. So this is IAB current, this is IBA current, this is IAB current, again this is IBA current. If we draw the source current waveform, nothing but how much current is passing at this point. The T1, T2 is on, the source current is equal to load current, that is equal to positive. Nothing but alpha to pi plus alpha, T1, T2 is conducting. So what is the waveform is there from this point to this point, you take the same waveform and draw it here. That is positive. Again pi plus alpha to 2 pi plus alpha, T3, T4 is conducting, the source current becomes a negative. So we have to draw the same waveform in the negative axis. Again T1, T2, so we are getting positive current, here negative current. If you see the load current always maintain the positive current, but the source current is alternating current. The current which is supplied at this point is alternating current, but it is not a pure sine wave. Now if you want to find out the average output voltage, alpha to pi plus alpha, nothing but from this point to this point, what is the waveform is the same waveform is repeating. So base length becomes a pi. Next we have to find out the area under this curve. We are using the integration 1 by pi integral alpha to pi plus alpha Vm sin omega t. If you complete this integration, you are getting the 2 Vm by pi cos alpha. The same circuit operation if you are keeping in the table, Alpha to pi plus alpha, nothing but alpha to pi plus alpha. From this point to this point, T1, T2 is conducting, the output voltage is VAB. Again, pi plus alpha to 2 pi plus alpha, T3, T4 is conducting, output voltage is VBA. Next, again, T1, T2 is conducting. If you find the average voltage versus firing angle, in this circuit, you can change the firing angle from 0 to 100 degrees. Take the firing angle on the x-axis, average output voltage on the y-axis. Alpha equal to 0, the average output voltage becomes a 2 Vm by pi. Alpha equal to 90, the average output voltage becomes a 0. Alpha equal to 100 degrees, the average output voltage becomes a minus 2 Vm by pi. We are getting this point. If you line join the 3 points, we are getting this type of curve. Nothing but the firing angle changing from 0 to 180 degrees, the average output voltage will be changing from positive to the negative. The firing angle less than the 90 degrees, the average output voltage becomes a positive. More than the 90 degrees, the average output voltage becomes a negative. But load current always positive. So for continuous load current, if you are maintaining the firing angle less than the 90 degrees, source is giving a power that should be taken by the load. The firing angle more than the 90 degrees, the load is giving a power that is given back to the source through this converter. That is possible only if the more inductance is present in the circuit. Nothing but some amount of energy will be stored in the inductance that is given back to the source. That is possible if you are maintaining the firing angle more than the 90 degrees. So this converter will be operating in a two quadrant operation. This is the first quadrant, this is the second quadrant. Nothing but the power is given from the source and taken by the load. But in this region, the power will be given by the load and taken by the source. But keep in mind, the load current is always positive, that is passing from top to the bottom only. The circuit does not allow in the current opposite direction of the load current. Thank you very much for watching this video.